Hello. Hello. Okay. Good morning, friends. So in the last classes, 6 classes, we covered the core subject, that is cell biology and genetics. And the university authorities have asked us to take up the elective subject, that is crop production, in 4 classes beginning from today. So today and tomorrow we have a class, and on the next Saturday and Sunday, 2 more classes are there, and we are supposed to complete the syllabus that is possible in these 4 classes only. So let us begin this with a brief introduction. And as you know, because of technical snag from the university, we are being connected by a late of 10 minutes. Okay, let us go and let us take extra time that we have lost in the beginning and try to complete the units that I have chosen today. As you know, the crop production, and in this there are 2 blocks. Block 1 deals with soil fertility, tillage and weed control. And the second block deals with the crop production of different crops. That is, there are cereals, there are pulses, and there are cash crops, and there are, fruit yielding crops. So let us confine ourselves to the first block. And in today's class, we will be discussing about the agricultural meteorology and soils, different types of soils that are there in Andhra Pradesh and Telangana, and the manures and the fertilizers. We confine ourselves only these 3 units in the leftover 60 minutes or so. So, okay, let us begin with agriculture meteorology. So, meteorology is nothing but that deals with what is called the environment, environmental conditions. Now, you might have heard about the climate and weather. These are the 2 common things, if you happen to listen to a news either on All India Radio or even on Doordarshan and on different news channels, at the end of the news broadcast, you will see the weather that is prevailing today. So the weather and the climate, of course, the weather is here the conditions that are prevalent in a shorter duration or in a shortened area. And whereas the climate, it is in broader area, maybe your state, or it could be the India or Asia, whatever the case may be. Here, the average climatic conditions, average weather conditions of that particular area, you get under climate, whereas weather, the present conditions, weather conditions that are present in that particular area in a short duration of that particular time. So now, what is this agricultural meteorology? Agriculture, as you know, which primarily depends on what we call the soil fertility, and the water. And apart from this, even the environment where, or the weather conditions that are prevailing in that area also influence your crop yield. Now, under this meteorology, we will learn about light, that is radiation. We will learn about the temperature and wind movement and the relative humidity of the atmosphere, then evaporation and rainfall, etc. So these are the climatic conditions that are known to influence your crop yield. So let us begin with light or the solar radiation. As you know, light or the solar radiation, so are the sun rays or sunlight. It is the primary source of energy for this entire planet. If there is no sun, there is no life on this earth. So the entire energy component of the world is being given out by the sun. Now, light comes onto the surface of the earth in the form of what we call electromagnetic radiation. There is no medium for the traveling of this light rays. These electromagnetic radiations being emitted from the surface of the sun reach the Earth's surface. As you know, it takes roughly 6 minutes traveling at the speed of light, So even so, sun and the distance between sun and the moon is, moon on one hand and the sun and earth is such a long distance. Now, what about the importance of light? Light, as far as crops, as far as plants are concerned, light, it determines what we call the source of energy, where the green plants or the chlorophyll containing parts, they trap this light, or more particularly this light energy is being converted into what we call chemical energy. Conversion of light energy into chemical energy is what is known as photosynthesis. So all green, all chlorophyll containing parts do this photosynthesis. Now, the other effect of this light is the light that reaches the surface of the earth, it heats. Because of when light rays hit, the warmth of the atmosphere, the surface of the earth gets heated up. Now, as you know, when the surface of the earth gets hot up, the air that is present, it moves up, it becomes lighter, and it makes upward movement because of expansion. So the heat or the temperature, to be more particular, heat and temperature of the atmosphere are because of light, electromagnetic radiation. Now, you'll be surprised to note that, roughly only 47% of the light energy is being retained by atmosphere and the earth. And the rest of the roughly 53% of the light energy is being re-emitted back or reflected back into the space. Only roughly 47% is being trapped by the Earth's surface, including the Earth's surface and also the atmosphere that forms an umbrella-like structure over the Earth's surface. So most of the light is being reflected back. So whatever the light that falls or that being taken up by the atmosphere or the Earth's surface, it heats up. So the temperature goes up. And because of that, various physiological activities, not only in plants, but all organisms. It is only because of the temperature and the light. If there is no light, no temperature. If there is no light, no life. So now this, coming to the light, the effect of light on plants, more particularly effect of light on crop plants. We'll study under two different heads. The light, as already told you, it reaches the Earth's surface in the form of electromagnetic waves, and this energy will be trapped by the chlorophyll. So for the synthesis of, not only for the synthesis of chlorophyll, but even for the conversion of light energy into chemical energy is being done only in the presence of light. So light energy is converted into chemical energy. That means the carbon dioxide gets converted into carbon-rich carbohydrates. So in the bonds of carbohydrates, the energy trapped is being stored. And this energy gets released during respiration. So both anabolic and catabolic. Photosynthesis is anabolic, respiration is a catabolic process. Now, we will discuss about this light, it's under three heads. The duration of the light, or the intensity of the light, the quality of the light, and the duration of the light. These are the three important factors that determine the growth of the plants or the crop plants in a given area. Now, first of all, the intensity. If the intensity is more, generally the tender parts, or even under high intensity, if it touches the leaf surface, there is every possibility for burning away of these delicate cells. So the intensity, if it crosses a threshold, it is deleterious for the crop growth. Now, coming to the quality. Here, what I mean to quality means here, if you pass a light ray through a prism, you will see splitting into 7 colors. That is Vibgea. This is what we call visible light. Now, this Vibgea below violet is ultraviolet. After red, that is far red. Both this. So, ultraviolet and far red, these are not useful for the crops. Now, this 400 nanometers, so roughly 700 nanometers, this is the visible light, and this is the photosynthetically active radiation. PR, photosynthetically active radiation. The energy that is there in different wavelengths, starting from violet to red, that is being trapped, that is being utilized by different types of pigment systems that are there in a leaf. Now, so here, you'll be surprised, the red is the most efficient light that is being utilized by the crops, or the chlorophyll, or the green crops, green leafy areas. So, and green, green is not at all useful for photosynthesis. Even, of course, violet is to a certain extent useful. So, green is the only wavelength or the light that is not useful in photosynthesis. Now, this is the quality. So, it is the wavelength. Of course, you will read about the importance of that further in your 6th sem when you read about the photosynthesis. Now, that is red drop, etc., etc. We will read. Now, so the intensity of the light, the wavelength, that is the quality, nature of the light. Then the duration of the light is also important for the crop yield or for the crop growth. That is for the growth, the development, and for the reproduction, for the flowering, initiation, for fruit, formation, seed setting, etc. are being under the control of these 3 important parameters of light. So here, the duration, based on the duration, is the relative length of the day and the night. Response of the plant or the crop plant to the relative length of the day and night is what we call photoperiodism. Based on this relative length required for a given crop, the crop plants are divided into 3 categories: long day plants, short day plants, and day neutral plants. Long day plants means that require more than a critical day length, maybe varying from 9 to 12 or maybe 9 to 13, 14 hours. Short day plants, less than that, less than 12 hours. That is short day. Day neutral plants means here the day length of the day does not matter for them. They flower, they produce, the fruit set, etc. will be there, even in short day condition and also in long day condition. So for a crops or for crops such as long day plants, long day crops, if they are exposed to short day conditions, of course they grow, but flowering gets affected. So is the case with short day plants. If the short day plants are exposed to long day conditions, the fruit set, flowering, etc. gets affected. So ultimately yield gets affected. So short day plants, as you know, long day plants. So for example, long day plants are, for example, our, your palak is there, your beetroot is there, your wheat, rice, these are all long day. Coming to short day, short day plants, for example, your tobacco is there, your chrysanthemum is there, xanthium is there, your millets. These are examples for short day plants. Coming to day neutral, your cucumber and maize, which are available throughout the year. For them, day length does not make any difference. So such plants which flower and fruit setting doesn't get affected by the day length are known as day neutral plants. So this is about light. Now coming to our next point, that is temperature. Temperature is the another most important weather weather component that determines, that influences the crop growth and crop yield. So coming to the temperature, now whenever we say temperature, generally we measure temperature, it is nothing but hotness. Temperature is nothing but hotness. Generally, we measure temperature by using what we call, thermometer, as you know. Whenever you feel like, weak, etc., when you feel hotness, generally you check your body temperature by using thermometer, which gives you your body temperature. Now, based on the instruments or the temperature measuring instruments that were invented, one is what we call a Fahrenheit and the other is centigrade. So they go by the name of the inventor, Fahrenheit and Celsius, centigrade. Now there is a formula for the interconversion. Say for example, your body temperature, whenever I say body temperature, 98 point odd Fahrenheit. If it is expressed in centigrade, it comes to what we call 37 degrees. So there is a formula for the interconversion. Say for example, if you want to convert Fahrenheit into centigrade, there is a formula. For example, C is equal to F minus 32 into 5 by 9. This gives you the measurement in centigrades. So if you want the same under Fahrenheit, if you want to convert centigrade into Fahrenheit, for F is equal to C into a 9 by 5 into plus 32. F is equal to C into 9 by 5 plus 32. That gives your Fahrenheit scale from centigrade. So, of course, there are, thermometers are there. Fahrenheit thermometer and centigrade thermometers are there. Of course, there in both of them, what do you see? The mercury. So mercury, you see, it responds well, it expands. So based on that, you determine the hotness in a given organism or an area. Even we have, even room thermometers also you have. By looking at that, you can say what is the room temperature. So these are now our most important thing is what is the effect of temperature on plant growth? Temperature also very, very important, for various physiological activities that take place in a plant body or directly or indirectly influenced by the temperature. Now, generally, there are, minimum, maximum, and ideal or optimum to say. Three types of are there. For example, the minimum temperature. See, minimum temperature means it is the temperature below which the physiological activity gets affected, even the growth and development of the plant gets affected. Now, the maximum means above that. Generally, maximum will be around 40 degrees. After 40 degrees, generally, your enzyme system gets denaturated. The rate of your respiration goes up. Loss of water through the plant body takes place. So that is detrimental for the growth and development of the plant or the crop. Now there is what we call optimum temperature. The optimum temperature for almost all the crops will be around 20 to 30. 20 to 30 is the ideal temperature for the growth and development of the crops and also for the various physiological activities that take place in the plant body. Now, what are the other things that are affected by your temperature? Even the seed germination. When you sow the seed, the temperature should be ideal. And if it is very cold, seed fails to germinate. Not only germination, even its establishment, formation of your shoot system and the root system also gets affected. So for ideal germination, for its establishment, for flowering, for all things, the temperature should be ideal. If it is very more than ideal temperature, that will be detrimental. So is the case with below the say for example, in most of the cases, except like your apples and other things. So most of the crops get affected if the temperature falls below 10 or so. Is very detrimental for plant growth. So for seed germination, for growth of the seedling, for the flowering, for fruit setting, even for the filling of the seeds, the temperature is very, very important. Even for various enzymatic activity, for each, if you increase the temperature, if the carbon dioxide and other are not are not the factors that are detrimental, for each degree of the temperature, you enhance the rate of various physiological activities get increased steadily. They increase steadily till what we call 35 to 40 degrees centigrade. Thereafter, they fall. So, that way, a temperature is very, very important factor for the growth and development. If it is very low, generally what happens? It is a chilling temperature. Then the water that is present in the cells, or more specifically between the intercellular spaces, whatever the water vapor that is there, or water molecules are there, they get crystallized. Thereby, they damage the cells. So it is very, very, that leads to what we call even the appearance of chlorotic spots on the leaves and other, because of this chilling injury. So you have what we call heat injury and also chilling injury. So the temperature should be very, very cardinal, or the optimal temperatures are very, very essential for the growth and development of the crop. Even if the temperature, soil temperature, if it is ideal, even the microbial activity in the soil also gets enhanced, and the availability of essential nutrients like nitrogen, phosphorus, and potash are available because of the microflora activity. So this is about the temperature. And now we move to what we call the wind movement. Now wind movement of the wind is influenced by what we call temperature and pressure. Temperature and pressure, these two are inversely proportional to each other. The temperature is high, generally pressure will be low. If the pressure is high, temperature will be low. They are inversely proportional. And these two parameters in turn influence the wind movement. Now wind, generally wind makes what we call horizontal movement from one place to other place, generally from higher pressure areas to lower pressure areas, wind blows. Now this is a horizontal movement, and in some cases, when the hair gets hot up, it expands and it moves up. And when it moves up, it expands, and because of the low density, and after reaching certain height, it gets cooled, and that air which moves up, it has what we call water in the form of water vapor. Now when it reaches a certain height where the temperature falls, then the water vapor molecules, the small droplets of water, they coalesce, they unite, and ultimately your raindrops. So when it reaches 0.2 mm size, then the upward thrust of the upward moving hot air will not be in a position to stop the falling of those 0.2 mm raindrop. So in such cases, the water vapor that got cooled in the higher areas comes down in the form of rain. So here, the wind movement, as I already told you, it is affected by the temperature and pressure. Already I told you, the wind moves in a horizontal and also in vertical. So vertical movement is what we call the current. And this vertical movement is the reason for the formation of what we call clouds and rainfall. So clouds and rainfall or because of the hot air, hot wind moving upwards. Now, you might have seen on the big, buildings, you will see some arrow-like instrument will be there. This is what we call wind vane. It gives you the direction of the wind blowing from south to north or otherwise. So this is what we call wind movement, and this gives you which direction the wind is making move. Now, even this determines our what we call monsoon also. We have in June and July, we have southwest monsoon, and during October and November, northeast monsoon. So during that time, even you will see clear-cut, change in the direction of the wind movements. Now, the wind velocity, there is an instrument, what we call anemometer, and Robinson's cup anemometer, that helps you to determine the speed of the wind that is blowing. Now, what is the effect of wind on the crop? How the wind movement affects your crop growth and development? Generally, wind, if it is gentle wind blowing is very ideal for the crop growth, because it removes or it helps in the gaseous exchange. So crop plants or the green plants, they take carbon dioxide from the atmosphere and give out oxygen into the atmosphere through a process what we call photosynthesis. When the wind is blowing gently, generally this photosynthetic rate goes up. Now, if there is gust of wind, if the winds are blowing with heavy speed, they are detrimental. Under such high winds, generally there will be shedding of entire crop, or the breaking of branches, your stems, etc. Your lodging of the matured crop will be there, and a lot of loss will be incurred by the farmer if the heavy winds blow. We have seen the other day. Generally, in America and other countries, you will see what are tornadoes, devastating tornadoes. They left even your cars also, cars fly high like your kites under the effect of those tornadoes. So the gentle wind, if the wind is blowing gently, that is very good. But if the wind blows with heavy speed, those are detrimental for crops, growth and development. Now, what are the other benefits of wind? Wind helps what we call, it brings you, cooling effect on the surface of the crop, and also for the drying. See, for example, in the next class, we will learn about what we call the tillage. There, by using your plows and harrows, etc., you bring the lower or the soil particles that are lying inside up, and upper soils will be turned inside. So there is a mixing of the topsoil and the undersoil. Now this, if there are rains, for sowing to occur, it has to get dried up. So your blowing winds enhance the drying. And the other thing is, for example, after harvest, what you need for the separation of this fully filled grains and the chaff, they have to be separated by what we call winnowing. If wind is blowing, it becomes easy for us for the separation of filled seed with chaff. Not only that, even for the what we call pollination, for the cross pollination, it is done by your insect and also by the anemophily, that is aided by your wind. For pollination, for cross pollination, wind is very, very important. Now, the other things, say, for example, we nowadays we are using wind energy. Windmills are there. So like this, wind energy is being used in many ways, even for the growth and development of the crops. For the better yields, we need wind. Then the humidity, relative humidity, the effect of relative humidity on the crop growth. Now, if the wind if the atmosphere, if the relative humidity is very high, under those conditions, the soil water will be more, and farmer need not to give 2 or more irrigations because sufficient water is there in the soil. So if the humidity of the weather or the atmosphere, relative humidity is high, under those conditions, the irrigations are not at all needed. Very good for growth. But if the under those conditions, the pests, that is your insects or bacterial or fungal diseases, they spread very fast. If the humidity is more, the spreading of disease causing organisms, it is highly prevalent. On the other hand, if the relative humidity is less, then the availability of the moisture in the soil gets lessened, and plant or the crop faces what we call drought-like condition. So that is not at all good for, and especially when the plant is in flowering and fruit setting or seed setting times, they are very sensitive for this moisture stress or water stress. If water is not available, then seed setting will not take place, and your yield gets affected. So this is what we call, effect of humidity. Now, of course, evaporation is there. There is loss of water. Loss of water through surface of the land is what we call evaporation. If the same is lost through plant bodies, that is leaves, etc., we call transpiration. In both the cases, it is the relative humidity, it is the temperature, and it is the water bodies that are there in the vicinity of the crops, etc., determine the rate of evaporation. Now, then we move to what we call clouds and rainfall. As I already told you, the clouds are nothing but, the hot air which moves upward. And this air has what we call the moisture, water vapor. Water vapor is there, and these water vapor, as the way hot air rises upwards, it expands and forms clouds. When this water vapor mixes with, various gases or the dust particles that are there in the atmosphere, combination of those make what we call clouds. And when these clouds, when the temperature falls, when in the higher areas it is very cool, then these water vapor molecules, they coalesce, they fuse and form what we call, if they reach 0.2 mm or more, generally it comes down in the form of rain. Now, rainfall. Now, this is very in examination, rainfall and types of rains are very, very important. And, generally we get rains or types of rains are of 3 kinds. One we call rains due to convection, rains due to cyclones, and rains due to what we call mountain barriers, orography. Now, rain due to convection, this is the very common phenomenon wherein I told you, when the hot air comes, and generally, this moving is influenced by the pressure and the temperature. Generally, it always moves from higher areas to lower areas. So when the wind comes from different areas with different temperatures and pressures, generally it leads to what we call cyclones. Cyclones, they arise from the sea surface. And they have, a lot of moisture in the form of water vapor, and that goes up and comes down in the form of, torrential rains. Such rains we call, cyclones. Generally, cyclones are seen mostly in the temperate areas. Whereas our rain due to convection, wherein the water vapor, the small droplets of water, they fuse and come down in the form of what we call rain. That mostly occurs in tropical areas, the areas which are very near to equator. And the third one is what we call rain due to mountain barriers. When moisture laden currents are the wind blows, when the high ranging mountains, they abstract the movement of the wind laden with moisture. So because of that abstraction, they come back and they rise up. And when they get cooled, again it comes down in the form of what we call rain. So like these rains occur mainly, our types of rains are mainly due to convection, cyclones, and the mountain barriers. Now the rain is measured in the form of what we call rain gas is there. It is mostly expressed in the form of millimeters or centimeters. Now the effect of rainfall, rain is mostly very, very important factor for the crop to grow. If the rainfall is high, if the rains are good, if they are not erratic, in those areas generally crop yields will be more. And in some areas the rainfall is very less and is erratic. In those areas they face drought and the crop yields are very, very less. Generally yields are more in the areas where you receive copious amount of rainfall. And in other areas like Rajasthan areas or in our Telangana area, your Mahbub Nagar or Rangareddy areas or Anantapur and of Prakasham of Andhra Pradesh, generally they are the dry areas where the rainfall is not only less but even erratic. So in such areas generally crops, generally crops of drought resistant, your bajra, sorghum, etc., or our pulse like your groundnut, etc., are grown, your castor, etc. But in the areas where there is a copious amount of rainfall, generally the soils will be good, and in those areas generally farmers prefer to grow rice, your sugar cane, even other important crops like your cotton, etc. So the rainfall is the most important factor that determines the crop yield and also the which crop the farmer wishes to grow. So this is about these are the various environmental or weather conditions or meteorological factors that determine the crop. Then we move to what we call soils. Soils, as you know, what is soil? Soil is nothing but superficial layer of the earth is nothing but soil. Soil is very, very rich. It is richer than your gold or platinum because it is never lost. It is sustainable. Generations after generation, people are living mainly by growing your crops, and your life sustenance is because of the presence of these fertile soils in a given area. So the soils, how the soils are formed? It is because of a phenomenon called weathering. Weathering is the phenomenon. Because of that weathering, the parental rocks, the big boulders, big rocks that are present underneath the surface of the earth, they get exposed to your variance in climatic conditions like your hotness and rain, cold, etc. When they get repeated, it is not in 1 year or 2 years. For the formation of, you'll be surprised, for formation of 1 inch of soil, it takes more than 1,000 years. So that's why it is the precious thing that is there on this globe. Now the soils, soils, mostly there are 3 types of soils are there. One is sandy soil, the other is your alluvial soil, the third is what we call black cotton soil. Black cotton soil. If these 3 are in equal proportions, they give rise to what we call another type of soil, that is what we call loam soil. Loam soils are very fertile because they have good water holding capacity, the aeration is very good, the microbial activity is very good, and so that's why they are the rich soils for growing various types of plants. Now sandy soils, where the sand component is more and your organic component will be less and water holding capacity is very less. And generally you find these sandy soils along the what we call east coast. Say for example, if you take your unified Andhra Pradesh, starting from Srikakulam to that of Nellore, on the coastal area, you see sandy soils. Now, these sandy soils, they are not rich. Why? Because their water holding capacity is very, very poor. And because of there are no water holding capacity, and even the microbial organisms, are less. So because of that, generally they do not support the growth of various crops. Generally, crops such as what we call in sandy areas, generally they grow maybe in areas where good rainfall is there. They may go for what we call growing of certain vegetables. But most of the areas, generally they grow casuarine or cashew plantations, etc., are taken up. Now, whereas the second category, that is deltoic soil or alluvial soils, they are very rich, and generally you will find them, on the delta, where the river divides into two, and whatever the soil it carries along, it deposits in the mid area, and that forms your delta. And we have, big delta is our Ganges delta area, and we have Godavari delta and Krishna delta, Kaveri, etc. And these delta areas are the soils of these delta areas are very rich, and they are called alluvial soils, and they're very fertile, and you can take up various types of crops. You can grow your rice, your sugar cane, even you can grow what we call cotton, tobacco, whatnot. All types of crops can be grown, even vegetables can be grown, and fruits such as your banana, etc. All types of crops can be grown in the alluvial soils, and generally we find these alluvials generally in the Krishna and Godavari basins in IAP. Generally, then third one is, of course, black soils, and of course these are two types, black soils and black cotton soils. Black soils are generally, they are medium deep, and their length will be 45 to 90 centimeters, and generally you come across them in mostly in Telangana area, Adilabad, Nizamabad, Warangal, Khammam area, and parts of Mahbub Nagar, Hyderabad, and in Kurnool, Anantapur, and Nellore and Guntur districts. There, the black soils are there, and they are good for growing jowar, bajra, pulses, your till or gingerly, cotton, tobacco, groundnut, etc. And if the water facility is available, generally in those areas, you can take up what we call rice and sugar cane. Then the black cotton soils, see, they are heavy soils. Black cotton soils are very heavy soils, where their depth varies from 90 to 180 centimeters, and generally they are there in Guntur, Prakasham, and Kadapa, and Kurnool areas of Andhra, and Adilabad, Nizamabad, and Warangal, Mahbubnagar, and Khammam areas of Telangana have what we call black cotton soils, and as the name indicates, they are very good for raising your cotton. Black cotton soils. So apart from this, we have what we call laterite soils. Laterite soils are soils, generally the red soils. Red soils are laterite soils. Generally, their pH will be around 4.5 to 6. Generally, they are they have their low nitrogen content and phosphorus content, and potassium will be, of course, in the required amount. And generally, they are there in certain areas in Kavali of Nellore and Zahirabad of Medak district. They have these laterite soils, and generally these laterite soils are very good for what we call raising tubers, rhizomes, like your potato, turmeric, ginger, tobacco, etc. are grown. Okay, now we learn about what we call problematic soils. Soils, of course, we learn. Then what are problematic soils? See, unless and until you take up some what we call some reclamation measures, these soils are unfit for growing crops, or rather uneconomical to begin with. So such problematic soils, they have to be reclaimed. Reclamation of the problematic soils. So soils which cannot be used economically for the cultivation without adopting proper reclamation procedures are called problematic soils. These problematic soils are primarily of three kinds, what we call acidic soils, basic soils, and eroded soils. Acidic, basic, and eroded. Now, what do you mean by acidic? Generally, these acidic soils you come across in the areas where there is a lot of rainfall, where the flooding occurs, where the stagnation of water takes place. Where if the stagnation takes place, if the water lays in a given area and it remains there for days together, generally it leads to what we call, because of the stagnation, it leads to whatever the salts that are there, whatever the minerals are that are there, when the water sinks, along with that, even these minerals are carried deep into the soil. This we call what we call leaching. Because of the loss of these phosphorus, calcium, potassium, etc., the soil becomes what we call acidic. So these are exchanged by hydrogen ion. So because of that, hydrogen ion concentration goes up, that way leads to what we call acidic soils. Now these acidic soils are not good. So generally you see these such as acidic soils in the northeast, in Assam, your Seven Sisters, and even Bengal and Orissa areas, and in the Western Ghats also, we can come across such acidic soils. Now, how can you reclaim? So acidic soils, here acidic means here the pH will be less than 6 or so. So strongly acidic means if the pH is around 5, it is strongly acidic. So it should be around 7. So strongly acidic soils can be reclaimed by adding what we call lime. So you are adding basic. So thereby you neutralize this acid base, and it comes to the pH comes to around 7. So by adding what we call limestone or even burnt lime, etc., you can reclaim the acidic soils. Now coming to the basic soils. So here the basic soils, where the important elements of calcium, potassium, your phosphorus, they are exchanged for your iron, your copper, aluminum, etc. So the concentration of iron, copper, aluminum gets enhanced in place of what we call calcium, phosphorus, magnesium, etc. So such soils where the pH is more than 7 are known as alkaline soils or basic soils. Even they are all unfit. So they can be reclaimed by adding what we call gypsum, calcium sulfate, or by adding what we call sulfur, etc., or by resorting to various agronomic practices such as dividing the field into various plots and flooding it with water, and this flood has to remain 3 or 4 days, and then you have to drain it out. By doing this repeatedly, you can bring them to normalcy, and that is how you can reclaim these soils. That is what we call reclamation of the soils. And the other is what we call eroded ravines. So the areas where if the soil is not flat, if it is steepy, and if it is not checked, the flowing water, it carries the topsoil, and you will see the removal of the topsoil, and you will see pebbles and rocks underneath. Such soils are not suitable because water holding capacity is lost. Even the topsoil is not there. So that's why you cannot raise any crop. So they have to be reclaimed. So for that, you have to make bunds. You have to grow vegetation. You have to add, bulk and organic manures. And even the silt, you can bring the silt from the other areas like your tanks, etc., and you can fill those ditches or the ravines, etc., and thereby you can make it a little bit flat, or you can make what we call trenches, step-like. By doing so, for resorting to such things, you can reclaim such soils. So they are now fit for cultivation. So now These are the problematic soils. Now, we'll learn about the meaning of soil fertility and soil productivity. Now, what do you mean by this soil fertility? Soil fertility means the ability, inner capacity of the soil to supply essential nutrients for the crop in right time is known as a fertile soil. So fertile soil it is full of essential nutrients. It supplies the nutrients that are needed for the crop in right time, so that your crop grows well and you get good yields. Now, what is this productivity? Productivity is nothing but the refers to what we call ability of the soil to yield. If the yield has to be high, if the yield is high, then we term such soils as highly productive soils. So here for the yield, it is not only the soil, but even other things like your climate, your temperature, your rainfall, your wind, and what we call cultivation practices do determine the productivity of the soil. So not only soil, its minerals, but even the temperature and the rainfall and your agronomic practices which you undertake, right time sowing and removal of the weeds at right time, irrigating the soil at right time. So these are some of the practices, and going for crop rotation, etc. By doing such agronomic practices, you can enhance the soil productivity. So now why fertility is lost? Why fertility is lost? Fertility is lost, because you are going for multiple cropping. You are raising crops for centuries together on the same plant without any break. So that's why it loses all its nutrients. So nutrients are removed by the crops. Nutrients are removed by your weeds, and also some nutrients are taken away by the erosion, maybe your wind erosion or your water erosion. They get washed away, and even some amount of nutrients are leaching. They move deep into the soil. They are not available for the crop or root system. So these are some of the, and even there are certain nutrients are not, because of in the gaseous form. For example, thiobacillus denitrificans. It converts nitrates into atomic or dinitrogen form. So these are some of the reasons for the loss of fertility of the soil. How can you reclaim? Reclamation is by adopting various agronomic practices and addition of your manures, etc. You can reclaim by going for what we call crop rotation, etc., mixed cropping. These are some of the agronomic practices. By doing that, you can replenish. You can make the soil again fertile. And the other process practices, for example, instead of growing repeatedly, you leave that soil, that field fallow without growing for 2 or 3 years, and you add what we call various manures by what we call crop rotation and addition, soil amendments, etc. And by doing what we call biofertilizers, etc. You can do this. Now in the next we'll discuss about what we call soil erosion. This is also very important examination point of view. What is erosion? Removal of the top soil, top fertile soil by either by water or by wind is known as erosion. So if it is by water, we call water erosion. If it is by wind, we call it wind erosion. Soil erosion, if it is the topsoil is removed in the form of smoothly, that we call sheet erosion. If it is in the form of small channels, rill erosion. If it is big channels, gully erosion. If it is prolonged gullies, that leads to what we call ravines. And if the topsoil is removed by your wind, that we call wind erosion. Generally, wind erosion we will see in our western India areas like your Rajasthan and Gujarat areas, where you will see blowing of winds. They carry the sand from Thar areas, etc. So they carry your topsoil one way, and they bring your soil, sand particles onto the. So this you can break by growing vegetations, that check your blowing velocity of the wind, and by constructing certain dams, certain embankments, you can check the running water and you can make it walking. Running water has to be stopped so that it moves very slowly. So by doing your what we call practices as mechanical, agronomical, and forestry, these are the three practices, conservative practices to check the soil erosion. Mechanical means here you construct bunds to check the velocity of the water, bunds. And then what we call the other is by by rock fill dams and by bench terracing in the form of steps, etc. So where the speed of the flowing water will be checked. Then agronomic practices, say for example contour cultivation, wherein you plant against the slope. Contour cultivation, that is. And the other, what we call strip cultivation, strip cropping is the other thing. And the lay farming, that is, do not cultivate, leave the field uncultivated for 2 or 3 years. Then crop rotation, not to go for same cultivation of the same crop, but change it. Grow a cereal, then go for a pulse. So alternate with a pulse and a cereal. This is what we call mostly crop rotation. The final is forestry measures. Forestry measures to check wind erosion, etc. You grow wind checking crop, plants such as your big trees, maybe shrubs, etc. And neem, tamarind, dalbergia, etc. And if it is a flat area, there you cover it. You encourage the growth of various grasses. They bind the soil. So whenever there is a water drops, they hit the surface of the grass, not the soil particles. Even if the blowing wind also, the blowing of soil particles will be checked if it is covered with greens, maybe your grass or wind breaking trees. So these are some of the practices whereby you can check the soil erosion. And finally, we move to what we call the manures. So now, just now we discussed, because of the repeated growing of the crops and because of the high infestation by the weeds and leaching, because of the leaching, etc., and because of erosion, the topsoil or the mineral-rich soil is lost. Now we should do what? We should replenish it. So replenishing of the soil by adding manures and fertilizers. So what are manures and fertilizers? Now here they make the addition of these manures and fertilizers. They make infertile soil. They bring back the fertility. They bring back the fertility of the soil. Now it is because of this use of fertilizers we achieved what we call green revolution. So green revolution, as you know, it is because of yielding varieties, your irrigation facilities, use of your organic these chemical fertilizers, and pesticides, etc., and better managerial practices, better your marketing facilities. Because of these practices, we achieve self-sufficiency in food grains. That is what we call green revolution. Now, in green revolution, one of the important components is your fertilizers. Now, for our convenience, we divide these fertilizers into 3 categories. One is organic, inorganic or chemical fertilizer. The other is biofertilizer. Organic fertilizers. Organic means something related to your living organisms. Here, living organisms means your cattle, cattle dung, cattle urine, and the leftover the stubs, even your fodder, forage, all these things. The leftovers, they get mixed with urine, dung, etc. If they are placed in a trench or in a what we call in a pit for 4 or 5 months, if you cover it either with a dung or what we call mud, etc., then it gets putrefied because of the activity of microorganisms. It gets digested, partially digested, and that leads to what we call your manure, organic manure. The other is even in your what we call not only your farmyard manure, even the compost. That is the compost from your sweepings from the houses, your vegetable waste, your kitchen waste, etc., your ash, etc. If you are using what we call firewood as a cooking for cooking, and the ash that you get, all these, if they are heaped, and they also give what we call your compost. So farmyard manure is there, your compost is there. They come under what we call your organic. The other organic is, for example, even your from slaughterhouses. They are known as, they are concentrated. They are concentrated things, and these concentrated organic manures are nothing but your oil cakes. That is your oil seeds. You mill it, and whatever the cake you get, either you can feed it to the cattle, and if it is a cake from your castor, etc., that is not consumable, that you can powder it and add to your soil. And your blood meal from slaughterhouses, you get what we call the dried and powdered blood, and the bones, and from fisheries, whatever you get, fins, etc., the the putrefied and non-edible carcasses or catfish, etc., they are powdered, your bone, horns, etc. Whatever the material you get from the slaughterhouses, that can be powdered, that can be dried and powdered, that can be added to your, so that becomes your concentrate. Even the night soil, or the what we call podrity, that is the night soil of the excreta of the human beings, also in some countries is being added to the soil. That becomes what we call podrita. Now the fertilizer, that is second, is what we call inorganic or fertilizers or chemical fertilizers. Some of these chemical fertilizers are classified into NPK. These three are very important: the nitrogen fertilizers, phosphatic fertilizers, and potassium fertilizers. So nitrogen fertilizers, of course, nitrate fertilizers are there, ammonium fertilizers are there, your nitrate ammonium fertilizers are there, and phosphatic fertilizers, of course, the phosphates you get from rock phosphate. Generally, the phosphates are rich in certain areas in the form of rocks in USA, Morocco, etc. There you see rock phosphates, and in good olden days, we used to prepare superphosphate by treating these bones with sulfuric acid. We used to get what we call the rock or superphosphate. Now, even the bone meal and the basic slag from steel industry also forms what we call the phosphatic fertilizer. Potassium is, of course, our muriate of potash is there. That is potassium chloride, potassium sulfate. These are some of the potassic fertilizers. Now, other are what we call DAP, that is compound fertilizers, very not one. So here in nitrate fertilizer, the nitrate rich, and the other is phosphatic, where phosphate is rich. Potassium, where potassium is rich. But there are compound fertilizers or complexes, what we call DAP, diammonium phosphate. You have ammonic fertilizer and also phosphates. And this DAP is one, and urea is one, where which is organic. Of course, it is a synthetic fertilizer, synthetic chemical fertilizer. First organic fertilizer produced in a factory, which is very rich in nitrogen only. And the last one, the most important, is your biofertilizers. Your biofertilizer, the term bio means here, instead of going for chemical fertilizers, now, of course, because of the shortage of your cattle, the organic or what we call the farmyard manure, etc., is getting lessened, and even that is not sufficient. So even repeated use of chemical fertilizers, the cost input is going up, and even that is spoiling the fertility of the soil. Too much excessive use of fertilizers is spoiling your. So that is one, and so that's better to go for what we call biofertilizers. Biofertilizer, here you use living microorganisms or the cells. Either you add them to the soil, or you inoculate the seeds with these fertilizers and you sow them. So along with the growing seedling, even these microorganisms such as your rhizobium or your azospirillum or azotobacter, etc., or your blue-green algae. They grow. Say, whenever speak of blue-green algae, generally they in areas where rice is grown, there the stagnant water is there. In the stagnant water, you can see these heavy growth of blooms of blue-green algae containing Nasta, Cannabina, Alocera, Cylindrosperm, etc., which are all nitrogen-fixing cyanobacteria. So the either free living or your symbiotic or your cyanobacteria, all of them, they have the ability to fix atmospheric nitrogen. They convert dinitrogen into nitrates, thereby they add to the fertility of the soil. If you go for biofertilizers, it will not only cut your input costs, but it adds to the health of the soil. So this is about what we call the fertilizers. So this completes what we call, we had to rush through, of course, and so that is how we discussed about the agriculture meteorology, and we discussed about the types of soils and also manures and fertilizers. Now in tomorrow's class, we'll take up the other topics, and with this I'll conclude my today's session. Any doubt? This is a time for interaction if anybody is there. Monica? Monica, can you react? Have you any doubt? So please unmute Monica so that she can interact. If you have any doubt, she can talk to me. Any doubt, Monica?
No, sir. It's clear, sir. Thank you, sir.
Monica?
Yes, sir. Sir, class time is till 3:30 only. We have next class 4 o'clock zoology.
So if you have any doubt, you can ask me, or else I'll close the session. Okay, Monica, can you respond?
Yes, sir. Thank you, sir. No doubts. It's clear, sir.
University people, please unmute Monica's audio. Okay. If no query, let us call it a day. Okay, thank you.
Thank you, sir.